Let's take a look at number 1. I will go ahead and say that these are all parallelograms. You need to know that information to be able to solve this warm-up. We would kind of have to assume it. Now, number 1 is a parallelogram with one right angle. So number 1 got promoted. That's not a parallelogram anymore. That is a rectangle. Because it's a rectangle, we know its angles are 90 degrees. Therefore, number 1 is C. 5x plus 35 equals 90. That's how you set up that problem. Number 2. Number 2 is a parallelogram with 4 congruent sides. That makes number 2 a rhombus. We know in a rhombus, one of the properties is that the diagonals cut the angles in half. The diagonals bisect the angles. So I can add arc to my rhombus. Well, if that angle has been bisected, then 35 is equivalent to 5x. So number 2 is A. Number 3. Sorry, you're not doing anything special. You're just a plain old parallelogram. And in a plain old parallelogram, we know that consecutive angles are supplementary. So 5x plus 35 equals 180. D. Finally, number 4, we have a parallelogram who's doing something extra. A parallelogram with 4 congruent sides. So number 4 is a rhombus. We know one of the properties of a rhombus is that the diagonals they don't just intersect. They don't just bisect each other. They are perpendicular. So every time you see a rhombus, you should put 90, 90, 90, 90. 5x equals 90. That's kind of cool how we took all the same expressions but set them up all different ways in our different shapes. Is trapezoids. We are literally just going to write down the properties. We're going to write the properties down, and your homework assignment is going to be you figuring out trapezoids. It's like a flipped classroom. You go try all the properties, and then we'll go over it in class. Really pretty trapezoids there. Don't write this down. This is the definition. Don't write this down. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So we've got one pair of parallel sides. The other 2 sides are not parallel, because if they were, then it wouldn't be a trapezoid anymore. It would be a parallelogram. Now, there's certain words that we need to go over in a trapezoid. Please, on your family tree, mark your picture on your family tree. The sides that are parallel are called the bases. The sides that are parallel are called the bases. The sides that are not parallel to each other are called the legs. The sides that are parallel are called the bases. The sides that are not parallel are called the legs. All right, when you have 2 angles, like angle 1 and angle 2, that are surrounding a base, you call them together their base angles. Angle 1 isn't a base angle by itself, but 1 and 2 put together, those are base angles. Angle 3 and angle 4, as a team, are base angles because they surround the base. Okay? Let's get into the properties. Property number 1 is always the definition. A trapezoid has 1 pair of parallel sides. 1 pair. Do you know why we didn't have to say opposite? 1 pair of opposite parallel sides? Because how could 2 sides that intersect be parallel? They couldn't. You don't really need that word opposite, do you? It's superfluous. That's one of my favorite words, superfluous. All right, Mrs. Tanton, stop rambling. All right, the next property. Look at those angles and see if you can come up with the property yourself. So I'm noticing something. I'm noticing that this angle plus this angle equals 180. And this angle plus this angle equals 180. What about the base angles? What about 30 plus 80? That doesn't equal anything special, 110. What about 150 and 100? 250, that's nothing special. So the angles I pointed out, those are supplementary. Now, here's the name of the property. But please do not write this down, because I think it's kind of confusing. 2 pairs of consecutive angles are supplementary. That is the textbook property. If you're okay with it, since we call the angles that surround the base angles, are you okay if we call the angles that surround the leg angles? You will not find them called leg angles in any book. You won't find them called leg angles online. But I think it makes more sense to say the leg angles are supplementary, as long as you know what it means to be a leg angle. Next property. We need to define what a midsegment is. Go ahead and draw a midsegment on your trapezoid. The midsegment, you've heard this word before in a different unit. The midsegment simply connects a midpoint, see the tick marks, to a midpoint. Notice the tick marks. So the midsegment is just a midpoint connected to a midpoint. Midsegment, midpoint to midpoint. You don't necessarily need to write down the definition of a midsegment, just know what it is. Here's the third property. We just had to say what a midsegment was to say the property. The midsegment is the average of the bases. This is property number 3. This is property number 3 in words. This is property number 3 in formula form. The midsegment is the average of the bases. Add your bases and divide by 2. Now remember, the bases are not always going to be the top and the bottom. The bases are the ones that are parallel. That will give it away. Which ones are my bases? They're the ones that are parallel. The midsegment is the average of the bases. Add them up and divide by 2. Okay, now we're going to receive a promotion. We are no longer just a trapezoid. We are an isosceles trapezoid, a trapezoid with congruent legs. That happens to be property number 1. Add tick marks to your picture. The definition of an isosceles trapezoid is a trapezoid where the legs are congruent. So remember, here are your bases. Your bases are not congruent. That wouldn't work. But your legs are congruent. Trapezoid. Isosceles trapezoid. Oh, we knew there was a reason to name those angles base angles. What was the reason? We needed it for isosceles trapezoid. In an isosceles trapezoid only, because there's symmetry, the base angles are congruent. Yep. The leg angles are still supplementary. That hasn't changed. But the base angles are the same measure. It's kind of like, there's more. There's one more property. It's kind of like an isosceles triangle with its head cut off. And that turns it into an isosceles trapezoid. Just because you cut the head off, that's really morbid, sorry, doesn't mean that those angles down there change. You see what I'm saying? In an isosceles triangle, the base angles are congruent, so in an isosceles trapezoid, the base angles are congruent. The last property is, the diagonals are congruent. AC is congruent to BD. So all of these are because there's symmetry in our isosceles trapezoid. The isosceles trapezoid is about the left looking like the right. Okay? Diagonals are congruent.